This is a very, very beautiful design and very professional material D2 which we have used. Almost it's used for the cutting dies, the tool steel D2. Now we will check its strength, how much we can load it. Now first of all we will check its strength. You can see it is still straight. Now we will check its edge quality. Its edge is rounded, not the sharp edge. This is round edge. Now we will check on the iron, on the vise. This is a casting material, very hard material. First of all, we will start here. Here. You can see there is nothing on the edge. The edge is very straight, and you can see on the vise there is many of the tucks which the steel have made. You can see in the front of your eyes. The blade is gold. There is nothing on the blade.
Most butterfly swords that are mass produced today are made out of stainless steel. Typically they're made out of American Iron Standards Institute 420 stainless steel. This stuff is really easy to machine. It's soft and it's got a high chromium content, so it doesn't rust very easily. So you can abuse it from a standpoint of forgetting about maintenance. The downside is it's so soft that it's called butter steel. It cannot be hardened to weapons grade. Historically, the hardness of an actual Chinese butterfly sword was somewhere in the HRC 55 to 60 range. If you take a 420 stainless steel and you heat treat it properly, you're not going to get there. So it is never going to be a real weapon. It's fine for open air practice, but that's not the problem. The problem is that most of the weapons that have this 420 stainless steel aren't going to have the balance or feel of the weapon that you're supposed to be practicing. Next step up the ladder is 420J2. This has a higher level of carbon than the pure 420. There is some debate, but in my opinion, you can't bring it up to true weapons grade. It will not hold a fine edge. Some fantasy blades of Western knives made out of 420J2, and you might even see some entry-level blades sold online out of 420J2. I would not wish to risk my life on one of those knives. Moving up the scale, we get 420HC. HC stands for high carbon. It's another stainless steel. It does have more carbon. It is weapons grade. You will have to pay some maintenance attention to it. It can be brought up to HRC 58. You don't see a whole lot of butterfly swords made out of 420HC, but it's fine. The next step up is the 440 series. If you see a knife advertised as 440 steel, it may or may not be 440 steel from a good maker. Chances are very good that it's not properly heat treated. The heat treatment is critical. What's a heat treatment? It's a controlled process of heating and cooling a blade to ripen its characteristics. The heat treatment determines the final balance between resilience and hardness. It's the area that mass-produced Chinese swords fail at most frequently. You'll see a lot of stories on the forum complaining about this steel or that steel. It's not necessarily the steel. A lot of times it's because there was a piss-poor heat treatment. Everything Wing Chun and their associated forge send their blades out to be professionally heat treated. There is a different regime of heat treatment for different steels, and the regime is going to vary depending on what you're targeting for those final characteristics. When we design a butterfly sword, we want it to have an adequately hard cutting edge to do the job, but we don't want that edge to be so hard that the entire sword shatters the first time you use it or with frequent use. The next step up is the 440 series. 440A, properly heat treated, is something you might see on an entry-level Western style knife. 440B is actually a pretty decent steel if you heat treat it properly. 440C is pretty much a spectacularly good weapons grade stainless steel. There is a whole lot of opportunity for a 440B to be nearly as good as a 440C. Randall Made Knives, one of the most famous U.S. knife makers, uses 440B stainless steel for their stainless steel blades. They hammer them. This is made out of 440C. These gratings are actually arranged. They're not a precise point. Consequently, it's important to know who makes the steel. It's also important to know what kind of steel is it. On most butterfly swords, the advertisement is not going to tell you what kind of steel it is. If it's a sword that was imported, chances are the importer doesn't know what kind of steel it is, but the manufacturer doesn't want to identify the steel because it's a lousy steel. It's not an advertising selling point. There are very few vendors of butterfly swords who will tell you what the steel is. I would not be interested in training with swords where I did not know what the steel was and I did not have confidence that the manufacturer properly heat treated the steel, and I wasn't personally satisfied that the blade wasn't going to go flying off and crack on me, but that's a different issue. You will occasionally see forum posts of armchair knife aficionados explaining how you can't use stainless steel for a sword. They don't know what they're talking about. Like I said, most butterfly swords are made out of stainless steel, and if it's cheap stainless steel, your downside is somewhat limited because if it's going to fail, chances are it's going to dent, so you'll retire it. It'll be ugly, you won't want to use it, it'll dent quickly, but no one's going to get hurt. If someone takes a much harder but mis-spec'd stainless steel that is so hard that it's fragile and it breaks, someone could get hurt. You can see butterfly swords advertised as being made out of surgical grade stainless steel. Let's think about that claim for a second. What does a surgical instrument need for a surgeon to use it successfully? It has to be able to take an edge at least once for a short period of time, hold that edge. It should not drop a lot of carbon molecules into the wound. It's got to be a steel that can be sterilized. Where does it say that it has to be able to hold an edge throughout a combat fight or several combat fights? Where does it say that it has to be able to easily penetrate and cut through bone? It doesn't. When someone says surgical grade stainless, it means nothing. There is no accepted AISI rating for surgical grade stainless. All it really means is that it's probably. I could say the same thing about combat grade steel. They didn't identify the steel. You would expect combat grade would be some kind of a carbon steel. In one case, it's actually just a stainless steel. Hot drop forging is a process of making a couple of die, putting your sheet of steel in between the two die, slamming the top die down on the bottom die, and ending up with a rough blank. The rough blank then gets carved down to whatever sword you want. That's the process we did with the interval swords. You've got two routes to go. One, you can make an oversized set of die and then do a lot of hand grinding, which is what we did here. Or two, you can make a die that's pretty close to the actual size, in which case there's a certain degree of pitting that comes out from this process. You're going to have to scrap a lot of the blades. It's a manufacturing cost issue. The next level of stainless steels are the knife super steels. This 440C This is used by some of the top Western knife makers to make custom knives, particularly military knives. Corrosion resistance. It's easy to resharpen. It takes a fine edge. It's just a wonderful piece of steel. But the super steels are tweaks on the 440C. They tend to give up some of the corrosion resistance, in return for which they add other factors. They might add some better lateral stability. 440C stainless steel tends to be about 3 times as expensive as a carbon steel that does the same job. Some of the super steels, and they're up to the 3rd generation of super steel, by the way, some of those can be 3 times as expensive as the 440C. Let me spend a moment and talk about Damascus steel. True Damascus steel is Wootz. Wootz was an actual steel with a certain set of impurities. That's a bad way to say about something that improves the quality of the steel, but that's what it was. And the method of making Wootz was lost. These days, when you hear someone say Damascus steel, they're usually referring to a lamellar. More particularly, that lamellar is likely to be a decorative pattern rather than a set of straight grains intended strictly to improve the resilience characteristics. One of the techniques used to improve the resilience of a steel blade is the lamellar method, which means that your village smith or your armory would take a layer of carbon steel, heat it, pound it flat, fold it over, heat it, pound it flat, fold it over, and that's the method the Chinese used to improve the strength and the resilience of their butterfly swords. And they had to do it because their steel quality was not as high as it is today. You can find butterfly swords made using this lamellar method today. In most cases, the lamellar is intended to be decorative and it can't ever be brought up into the weapons grade of hardness. In some cases, it indeed is weapons grade in hardness, but not necessarily better than a good mono steel. You can make a lamellar out of either stainless steel or carbon steel. It's a lot more prevalent and easier to do with carbon steel. Being able to smith stainless steel takes a lot more skill. These happen to be stainless steel lamellar blades. They're about 300 layers, and they are weapons grade. And it's full custom work. It was expensive. Another method to improve the overall characteristics of the blade is differential tempering. And what differential tempering would be is you harden the edge to that really hard level that you want, and you leave the rest of the blade a whole lot softer. This happens to be a Porthau bread knife from Model Design LLC. It's the same Bowler 440C that we use for everything Wing Chun's flagship line. And we like to tell people, if you are ever attacked by zombies and you're in the kitchen, this is the weapon to use. Again, it's differentially tempered 440C. Now, when you differentially temper carbon steel, sometimes you can get a nice little line called a Hammond. It's not something we really worry about because we can get plenty of hardness and good resilience without moving to the differential tempering. But if you were doing a pair of full custom knives, it might be an interesting tweak to increase the value of the product.